Hi everyone. I'm going to record a series of 3 lessons about symmetry. With the first lesson, we're going to talk about symmetry with respect to a line. The second lesson, I'm going to talk about symmetry with respect to a point. And the third lesson, we're going to work through a few examples. So I'm going to start just by kind of reiterating what I just said, that for our purposes, we're going to be looking at 2 different types of symmetry. And I'm going to write that here. We have symmetry with respect to a line. And in our second lesson, symmetry with respect to a point. So in order to talk about symmetry with respect to a line, we're going to define what that line is called. So definition, it's called an axis of symmetry. So an axis of symmetry is a vertical line such that the graph looks the same, or even we can say identical, to the left and to the right of it. So let's look at an example, just kind of sketching an example freehand. So I'm going to draw on a pair of coordinate axes there. So here's our x-axis. Here's our y-axis. And then I'm going to dot in some vertical line. It can be any line you like, as long as it's vertical. So here I go. I'm dotting in the vertical line x equals 1. And then I'm going to draw the left half of this graph. You can really draw anything you want. You could be totally freeform about it. So I'm going to draw something that goes up, turns around here, and then comes back and does something like this, right? So that's the left-hand side of our function's graph. So on the right-hand side, it looks exactly the same. So it goes down to here, then turns around, and then up, and then over again, right? So this is not a perfect graph, right? We could kind of tweak it a little bit if we wanted to make it more perfect, but this is what it looks like to be symmetric with respect to a vertical line. For our purposes right now, notice I'm saying right now, meaning that later we'll change this. We will focus on symmetry about or with respect to the y-axis. So not just any vertical line, the y-axis. Now I have a graph prepared for us down here. Okay, so here's a lovely graph. You might notice I said what it is. It's f of x equals x squared minus 4. That's actually something we'll pick up again in the last of the 3 videos on the topic of symmetry. For now, I'm just asking you to look at the graph. So there it is. And what I want you to notice, and I'm going to use a few different colors here. If I pick a point on this graph, right? So for instance, here's one. So this point is the point 1, negative 3. Okay, and then I go over to the y-axis and then keep going until I get a point on the other side. What do you notice about this point? Well, its y-coordinate is still negative 3, but its x-coordinate is negative 1 now, right? For example, here's another point. Its coordinates are 2, 0. So if I do the same thing, if I dot over to the y-axis and then keep going until I get to another point on the graph. Oh, it has the same y-coordinate, still 0, but the x-coordinate is -2 now. If I switch to a different color, like maybe this lovely coral color, and I pick some other point on the graph, right, like maybe this one, I'm not going to specify its coordinates precisely. We'll just call them like A and B, right? And then I dot over to the y-axis and then keep going from there. You're all going to agree with me that this new point that I haven't labeled yet has the same y-coordinate as the point where we started, but the x-coordinate is opposite, right? So it's -A, comma, B. And then the last thing that I want to label on this graph, let's do it in this orange color. If I pick some point and its x-coordinate is whatever, let's call it x. Well, since this is the graph of a function, the y-coordinate is the output that this function assigns to the input x, which is f of x. Now, I'm going to do the same thing. I'm going to dot it on over to the y-axis and then keep on going until I get to a point on the opposite side. And again, you see that, well, the y-coordinate stayed the same and the x-coordinate is opposite, right? So the x-coordinate is -x. The y-coordinate is still f of x. But you know that this is the graph of a function. The y-coordinate of every point is the output that that function assigns to the x-coordinate input. So what we're seeing here is that a function f of x is, I'm going to sort of scroll over here so I have a little bit more room, symmetric about the y-axis if it assigns the same output to the input x and the input -x. In other words, f of -x is the same as f of x. So that is the function notation way to say what we've said in the last few examples. That if you take a point on the graph, there'll be another point on the graph with the same y-coordinate but the opposite x-coordinate. And the last thing I'm going to say in this lesson is a function that's symmetric about the y-axis is called even. So that's a lot faster to say. We say even rather than symmetric about the y-axis. So watch for the other two lessons, a lesson on symmetry about a point, and then a lesson with some examples. See you later. Bye.